Number 7. If A, stop. What is it doing? Okay. If A is an obtuse angle in a triangle and the sine of A is equal to 5 over 13. All right, I'm seeing some clues here. I don't want to forget. Obtuse angle, sine of A is this. Calculate the exact value of the sine of 2A. Okay. So whenever I have a fraction that looks like this, where it's not a fraction that's located on our chart of common trig ratios, right? You are going to have to draw a picture. That's the only way you're going to be able to figure this one out. So we have the sine of A is equal to 5 over 13. We have A is the angle that we're talking about. The trig ratio is 5 over 13, and it's an obtuse angle. So this is positive, so we're going to have to try to see which quadrant we should sketch this guy in. If sine is positive, it could be in this one, or it could be in this one. Can't be in these two. Let's look at our clue where it says it's an obtuse angle. Okay, well then that's going to eliminate quadrant 1, so I am in quadrant 2. So I am drawing my picture. Just give myself some more space. In quadrant 2. And it says that the sine of A, some unknown angle A, yeah, I have no idea what it is, but rotated into quadrant 2, it's going to look like this. Okay, so the reference angle is A. And the ratio of the sides are going to be 5 over 13, which is opposite over hypotenuse for sine. So I have opposite over hypotenuse. And now we want to calculate the exact value of the sine of 2A. So in order to get the sine of 2A, I'm going to need 2 times the sine of A times the cosine of A. So I have the sine of A. They gave it to me. It's 5 over 13, but I do need to calculate the cosine of A. So that's like what I'm trying to find out right now. So let's figure out what the cosine of A would be. Well, in order to calculate cosine for A, I need adjacent over hypotenuse, and the adjacent needs to be figured out. The way that we figure it out from the sketch is going to be 5 squared plus, let's just call him x. X squared equals 13 squared. 25 plus x squared equals 169. So then now I could either do the math or I could recognize that, oh my goodness, he's a Pythagorean triple. Do you remember Pythagorean triples, right? We have 3, 4, 5. In this case, we have a 5, 12, 13. But you could keep going with the work if you weren't sure about that. Okay, so this guy is going to be 12. So then now the cosine of A is going to be adjacent over hypotenuse, and that is 12 over 13. So now this is going to be a little bit of a math. Oh, hold on a second. So if I have this going in the negative direction on the x-axis, he's going to be at negative 12. Negative 12. Do you see that the distinction that I had to go back and make there? Okay, so this is negative 12. Cool. Glad I caught that. Didn't have to do this over again. Okay, so the sine of 2A is equal to, and then I have negative 12 times 2 is going to give me negative 24, and then times 5 is going to give me negative 120 over 13 squared is 169. And you don't have to reduce because it's no calculator. Boom. Oh, wait, we're highlighting. Excuse me.